we're going to talk about the second part of proportional relationships, how to recognize them from graphs. So we're just going to do a quick little sketch. We know that this is your y-axis and this is your x-axis. We're going to say that this is miles. Always start it with a 0 at the bottom. This is hours. Okay. So as we talked a little bit about before about that direct variation, this is an example of it that you can see a little bit more clearly because our line is climbing, therefore it's increasing. So as hours, which is my x variable, increases, miles, the y, also increases. That's why our line goes up in a positive direction. So as I'm coming across, my hours are increasing. 1, 2, 3, 4. And so isn't my miles. 10, 20, 30, 40. Okay, so we need to find k. Remember, k is equal to y over x. So k is equal to 10 over 1. And that equals 10. 10 is my y over 1 my x. K equals 20 over 2. That also equals 10. 20 over 2. K equals 30 over 3. That's also equal to 10. 30 is my y. Come over to the point and down. There's my 3. The last one we have here is k equals 40 over 4, which is equal to 10. Therefore, k equals 10, y equals kx, substitute, y equals 10x. So my equation for that graph would be y equals 10x. All right, there's certain criteria that we need to remember when we're looking at graphs and trying to determine whether they are proportional or not. Now remember, this is the unit rate. Wasn't it 10 over 1? So I'm going to abbreviate that. Constant of proportionality is your unit rate. We talked about that in our first notes, our first set of notes. We said it right here, that the constant of proportionality, which is represented with the letter K, is nothing more than our unit rate. That's what we're looking for. So the constant of proportionality is a ratio that represents our unit rate. So there are certain criteria that need to be met in order for it to be, or graphs to be proportional. Okay? All right, the first one. The graph must start at the origin. And that origin is 0, 0. And if we recall, every one of those tables that we looked at started with 0, 0. Every one of those tables started with 0, 0. So our graph must start at 0, 0, which is right here at the origin. If it doesn't start there, then it is not proportional. Number 2, the graph must be a straight line. And it is. Okay, it's a straight line. Our graph is increasing as X increases my hours, so don't the miles. It is a straight line. Okay, and it's a straight line because it has the same constant of proportionality. So this third one, all ratios must have the same constant of proportionality. Which is K. So if I look up above here, we did that. 10 over 1 is 10. 20 over 2 is 10. 30 over 3 is 10. 40 over 4 is 10. Okay, so our unit rate is 10. Our constant of proportionality is 10. That's what makes a graph proportional. Okay, so we're going to do just two more quick little examples. Okay, I'm just going to sketch a graph real quickly. Nothing fancy. My graph is off a little bit, but I think we can get the picture here, okay? All right, so we need to do K equals Y over X. Remember, X is always your horizontal line, Y is always your vertical line. Okay, so if I took my first one, K is equal to 100 over 20. I know if I divide those two, I'm going to get 5. K is equal to 200 over 40. When I divide those, my unit rate is 5. K is equal to 300 over 60. When I divide, I get 5 over 1, which is 5. And then the last one would be 400 over 80, which is also equal to 5. So K is equal to 5, Y equals KX, Y equals 5X. That would be the equation for that graph. That graph is proportional. All right, last one. All right, we have our Y, we have our X. Before I even start looking for the constant of proportionality, I want to figure out if that even is possible to be a proportional relationship. And the answer to that would be no. This is non-proportional. And I know that just by looking at it, because the graph does not start at the origin. So I don't need to do any additional work because this graph starts up here and it goes down. That's why the arrow is at the bottom of that line. So that line could not possibly be proportional because it does not start here at the origin.